My name is Douglas Galante. I'm a postdoc at the University of São Paulo in Brazil. There is one specific event that I'd like to talk. It's the event that I have worked in my PhD, which is called gamma ray burst. A gamma ray burst is the most energetic event that there is in the universe, on the known universe. After the Big Bang, this is the most energetic event. It's basically caused by the collapse of a massive star, something of the order of 100 sun masses, so it's a huge star that collapses, and it produces energies. It produces a lot of gamma radiation, about 10 to the 51 erg of energy just in gammas. So it's a huge amount of energy. It's almost the entire, as if we could convert the entire mass of the sun into gammas. So it's a lot of energy in hard electromagnetic radiation. And we have looked for the effects of this radiation hitting a planet. So what it causes is, most important of all, is a completely it's a completely change on the chemical composition of the atmosphere, because most of this energy is absorbed by the atmosphere. So it damages the ozone layer if you have a planet with ozone layer like Earth, and you produce a lot of NEO compounds. So this hugely changes the way the atmosphere interacts with radiation. A lot of UV radiation from the sun can arrive on the ground. So and these events can happen on the galaxy in a time scale of around 1 billion years or so, something like that. So it's a massive event. It produces a lot of gamma radiation that will change the chemical composition of the atmosphere, and it will also produce a lot of cosmic rays that will hit Earth. And that's another very much interesting thing that we are working on right now. That's because if you have a lot of cosmic rays, we are not so much interested on the primary cosmic rays, I mean the protons that are reaching the upper atmosphere, but on the subproducts of this, because they will cascade down the atmosphere, producing a lot of muons. And these muons are very much interesting because they have lower interaction cross sections with matter, so they can go deeper on Earth, so they can interact with life that is underground or underwater. So it has a greater possibility of a global impact, because most people say, oh, radiation event will only hit the surface of Earth, so that's not important because most of life is not on the surface but underwater and underground. But these muons can really interact with this life and produce damages even kilometer down underground. We're interested in understanding this muon problem, so to really understand what are the possible biological effects of these energetic particles, but we don't have an accelerator, or we don't have I don't think nowadays we have the conditions to perform this type of experiment. Maybe on some nuclear accelerator, but I really have to look for this because we need an energetic and great flux beam of pions to produce a reasonable flux of muons, but we can look for that.